Hello students, welcome back to Madhvi's Java programming tutorials. In this video, I'll be explaining you user-defined methods, introduction and access specifiers. Let's see the contents: introduction, advantages of methods, method declaration, parts of a header, which is access modifier, keyword static, return type, name of the method, and parameters. Let's start. In real life, we plan everything. We divide the work into several tasks. For example, preparing breakfast, the main task. It has several subtasks and sub-subtasks. For example, subtask 1, preparing something solid to eat. Subtask 2, preparing something liquid to drink. In the subtask 1, first of all, we think about what to eat. We plan and collect the ingredients, then cook. In subtask 2, coffee or juice, first of all, we decide, and then the drink is ready, whatever it may be. Similarly, in Java, the main task to be performed is known as program, which is defined in a class, and the program is divided into subtasks which are known as functions or methods. Now, a function or a method is a subpart of a program. It does a particular task. For example, we have created a program for TV object. There are several subtasks: increase volume, decrease channel, adjust contrast, and so on and so forth. In Java, there are several built-in functions or methods which are known as predefined methods or library methods. For example, math.sqrt, math.abs, scanner class, nextint, next, etc. methods. Programmers also define user-defined methods in user-defined classes. Together with the predefined and user-defined methods, Java programmers create programs. Now, each task or method should be planned and should be independent of other tasks. For example, reading and printing we cannot club because every time we want to print, it has to be read. So, planning is a must. Let's see advantages of methods. They make the program manageable. Why? Because we divide the program into tasks and each task will be typed and tested separately. And they make the program readable also. They provide better memory management. Why? Because the method which is being executed will be copied onto the RAM, not the entire program. So, better memory management. Once a method is written and compiled, it can be called anywhere, any number of times. For example, println method. Each and every program we call println method to print our output of the program. Now, method declaration has two parts: header, body of the method. Header is the first line of the method, which is also known as prototype. In the example, that red colored words void read int a is nothing but a header, the very first line in the method. Now, body is the rest of it, curly brackets, within curly brackets, whatever you write is known as body of the method. Now, parts of a header: access modifier, static keyword, return type, name of the method, and parameters. Each header has at most 5 parts. First 2 parts and last part, maybe the parameters, are optional. What are the first 2 parts? First part is access specifier. It gives access levels decides the access levels of class, methods, and member variables. And then second one is static keyword. We have seen static methods, instance methods. Then void. This is the return type. So far, we have written void methods, but we will be writing different type of methods. Return type we can change. Name of the method, some name. It is an identifier. We need to follow the rules. Then parameters within parentheses. If there are no parameters also, we need to give the parenthesis. Now let's see access specifier. This is also known as access modifier. Decides the access levels of a class, member variables, and member methods. These access modifiers or specifiers are not given to parameters and local variables. There are 4 types of access modifiers. First one is private, most restrictive, package level, public level, and protected level. Let's see private access. It's like a small toy possessed by a child who doesn't want to share it. Means private access can be given to member methods and member variables only. Because private means cannot be shareable, I cannot create a class with private keyword. Class private means nobody can use it. And protected also we cannot give. Now, this access specifier private can be given to member variables and member methods. And these members can be accessed only within the class in which they are declared. And these private members can be called from either public, private, or default of the same class. For example, class demo is there, demo class, in which 2 members are there, private index, that is member variable, private void HCF, which is a member method. Now, void LCM, public static void main, 2 more methods are there. So, private, public, we know, void LCM is not having neither private nor public, which is package level. We will see in the next slide also. But what we said, these private members can be used either in public or in private or in default. So private index is being used in private void HCF, x is equal to 5. And void LCM calling HCF as well as saying x is equal to 25. Public method also calling HCF, changing the value of x, no problems. Within the class, we can access. Now, if we go to package level, this access level can be given to classes, member variables, and member methods. If at all no access specifiers such as public, private, protected are not given, then it is known as a default level or package level. Package level members can be accessed within the class and within the package. We will see with the help of a Java program. For example, in a package, there are 2 classes. One is class demo, second one is class use demo. Class demo has 1 instance variable and 1 instance method. Void find int x. Now use demo is creating an object of demo class. This is how the classes in the same package can access each other by creating an object, or if the method is static, directly calling with the help of class name. So in class use demo and void calling method, we have created an object of demo class. Demo d1 is equal to new demo d1 dot find. We are calling a method of demo class in use demo. Let's see both private and package access specifiers in a Java environment. Let's see, first of all, what are all the access specifiers which can be used with the class? First of all, I did not give any access specifier here. What are all the access specifiers? Private, public, protected, and this is default. No access specifier. Control K, it does not give any error. Let's try private. Control K, it says modifier private not allowed here. A class cannot be private. Then let's give protected. Control K, modifier protected not allowed. So private and protected cannot be used. By default, we can use just class or public class. Control K, it works. And there is one more specifier which is known as abstract. This also works, but in inheritance we will discuss. So the possible access modifiers which can be used with class check is without any modifier or specifier, which is default or package level. Second one is public. Third one is abstract. Okay. Now this is a package. This area is known as package. In the package, I can access any of the classes without importing. When I don't write anything before the class or method or member variables, that is default access, or public. Private is most restricted. It cannot be used. I can create objects and use in different classes. We will see, and we have seen already. But let's concentrate on access specifiers. Now, two member variables are there. First one is private index. Second one is package level. There is no private, no public, nothing. So package level. Another private method HCF. Private, another private method, some method. Void LCM, this is package level, and one public method. Now what we said is private variables can be used in private methods, and private methods also can be used in private methods. So in void HCF private, it is printing in HCF and calling some method which is of private type. Control K, no errors. And also it is accessing a private variable x is 1, y is 2. In the class, anything can be used with everything. But private cannot be used in package. Only it can be used within the class. Now, this sum method is also accessing x, that is private in nature, and then void LCM can access all of them. Public can access all of them. This is about private, but we will try to use these private members in package class. Okay, let's double click on package, and package is ready. What we are trying to do is creating an object. In class package, in the method main, we have created an object private access specifier PR1 is equal to new private access specifier object created. Why? Because there are no static methods. Immediately, there is a line over here. That means package is trying to use the another class. This is perfect. In the same package, any class can create any object. Now, in this, I don't have static methods. So in order to call these methods, we need an object. Now, pr1 dot x equals to 5. It gives an error. Why? Because x has private access, which can be used in the class in which it is specified. This is one I want to explain. Second one, if I have to call control K HCF, this HCF is also private method which cannot be used in the package level. But LCM I can call. Why? Because it's a, let's see in private access specifier. LCM is of which type? Package level. So in the package, any class can create an object because it is an instance method, can call. So we have called. And then is there any smaller fraction method? LCM, some method is there. So we try to call, it gives an error. So this is how we can create an object and call the methods. Control K, no errors. Now, similarly, there is one more class called sum class. Let's see the contents of sum class. Sum class has a static method. I can directly call from any other class in the package because it has package or public level access. No problems. Public or package level, no problems. So in the package, if we call the method sum class dot main, main is a static method. Control K, immediately another line will appear. So this package class is accessing two classes. One is sum class, second one is private access specifier. Here, all of them are instance methods. In private access specifier, all methods are instance methods. That's why we have created an object. In some class, we have a static method. So we just called with the help of class name. Similarly, this search method can be called anywhere else. It's a static method. So with the help of class name, we can call search method. Let's try to call from some class search method of package class. Package dot search. Control K. See, this package class is using some class. So this kind of accessing is possible without importing. Without importing. Let's make all these things. We don't want any of these lines here because we want to understand now public. What is public? In case of public, not only these four, in this area, we can create new packages. Package name is A1, let's suppose. This is a subfolder kind of thing. Again, another package, A2. And inside which, whatever is there, I can't see in this area. So we need to import. We need to import. Whenever we create a package, immediately one statement will be there for each class we create. That is package A1. What is it? Package A1. This is created in package A1. Another class A A1. Okay. Another class. Each class will contain one particular statement called package A1. Similarly, go up in A2 package also, we can create different classes. Let's suppose B1, when I double click and see package B A2, this is in package A2. So these are kind of subfolders. Public access specifier, not only within the class, but also in the same package, but also in different packages, the methods and classes can be accessed. Let's go to PowerPoint slide, understand a bit more, and come back to this area again. So we have understood private and package level. Let's understand a bit more about public access level. It's like a public park. Anybody can go and spend some time over there. Just like public, anybody can access highest level of access. This can be given to class, member variables, and member methods. If a class is public class, then only public members of that class can be accessed in other packages. For example, a house is there. If the main door is locked, even if the doors inside the house, all the rooms doors are open, but still we cannot access. So if there are public members, that is public variables, member variables, public methods are there, but class is not public, the main door is closed, we cannot use them. So if at all we want to access from different areas, that is different packages, class should be public. Now public class members can be used in same class, classes in the same package, and other packages by importing the class. You remember import java.util. Just like that, user defined packages can be imported. Public class demo, public int x, public void read. These are all member methods which are public, member variable which is public, and demo class also public. Let's go back to our Java program and understand. Okay, the screen is divided into 4 areas. First area is showing 2 packages. In the use access specifiers project, I have created 2 packages. First one is package 1, second one is package 2. Now the contents of package 1 are shown over here. What is there? Class P1 is there. Class P1. Now contents of package 2 in the left hand side corner, P2. So package 1 has P1, package 2 has P2, which are not visible in the use access specifier. If they are accessible, they'll be directly shown in this project area. But they do not belong to this project area, but package 1 has P1, package 2 has P2. Now let's see the contents of P1. Whenever we create a class in a package, automatically one statement will come package 1. So this P1 class belongs to package 1. Now, if you see the contents of P2. P2 also has package 2. So in package 2, P2 class is there. In package 1, P1 class is there. Now we want to access each other. From P2, we want to access P1. From P2, that is in package 2, we want to access P1. So import package1 dot P1. Then it will understand. Otherwise, in this area, P1, P2 are not there. So import package1 dot P1 means I can use whatever is there in P1 class. Okay. Now, there is one method in P2 void disp which tries to call whatever is there in P1. Let's see what is there in P1. One instance method, disp instance. Another static method, disp static method. What are they? Disp instance, disp static. In order to, and mind you, please look at this. These are all public. Because in different packages I want to use, then they should be public. Class should be public, method should be public, and variables should be public if we directly want to access them. Now, this is instance method, so we need an object. And this is static method, not object is not required. P1 dot, we can say. So let's go to P2 and see what is written. Object is created, P1, it knows P1 is in package 1. P1A is equal to new P1. A dot disp instance because it is an instance method. And P1 dot disp static. What is there in P1? Instance method of class P1 from package 1. And static method of class P1 from package 1 is written in P1 class. Now, P1 first compile. See, this is compiled. P2, I am trying to call. Control K, no errors. That means accessing classes from different packages is, first of all, we need to import. And then onwards, creating object, calling static methods is simple. But the class which we are trying to access, what is that class we are trying to access? P1 class should be public. And the method should be public. But P2, there is no requirement. Just import. It can be a default class, it can be a public class, any class. But if we want to access P2 class in P1 class, then definitely P2 class should be public. This is what is packages and public access specifier. Okay. We have understood private, package, public. Now protected. Protected keyword can be given to member variables and methods. We have seen we cannot give it to class. It is used in inheritance concept, but let's suppose we have a bicycle and with our permission somebody can use protected. In inheritance, I'll explain this. Then this, out of 5 parts, we have understood public access specifier, public, private, protected, and package level. Now static, we know already, keyword static. Static keyword can be used with member methods and member variables. Static classes cannot be there. Are available to the class only, the methods. Value of the static variable is same for all the objects. And keyword static is optional. Math class methods are static methods and math.sqrt, math.pub, like that we need to call. Do practice exercises success of one of chapter 3 from the book Essentials of Computer Applications. This is the second book. Then return type we will understand in the next video, but little bit about return type. Whenever a main program calls a subprogram, first of all, the subprogram will be executed and the control will be returned back to the main program. Now, the subprogram may return a value along with the control. It depends on the return type. If a subprogram is returning a value, then in the subprogram, we use a keyword called return. Return X, return Y, return 4, return 10.5, something like that. Return. If this return statement used in if else ladder, only one return statement will be executed depending on the condition which is true. Then a return type determines whether a method is returning a value or not. If it is void, then only control is returned. If the return type is valid primitive data type, that means that method is returning primitive type value. For example, int read, not void read. Then I need to have a statement because integer I'm trying to return. So return 5. That statement should be there. If a function or method returns object, it could be user defined or a library class. See the example, string name, not void name. Return some string in double quotes or a variable, string variable. Then name of the method, very easy. We know that can be any name relevant to task. It's an identifier. So public void print, it should follow all the conventions of the identifier. And then parameters, optional. Here a little bit I explain. Parameters are the variables declared at the function header or method header. Header means the very first line. These parameters can be found in two places. One is in method header, which are known as formal parameters or just parameters, and in method calling, which is known as actual parameters or arguments. See, method header formal parameters, class search is there, static void read, int ab. These int ab in the definition part where header is there and body is there. Such kind of parameters are known as formal parameters. But when we call this method, let's suppose class search 1 is there. I'm trying to call reading xy, calling the static method read from search class. So search dot read x and y I'm passing because this method read requires two parameters. So this x and y while calling read are known as actual parameters or arguments. Or it can be like this also, search dot read 4 and 5. Integers. These are also known as actual parameters. So at the method header, formal parameters are parameters. And while calling a method, we use some parameters. Those are known as the similar parameters which are expected by the method. Actual parameters are arguments. method calling actual parameters, method header, formal parameters. Refer chapter 3 of Essentials of Computer Applications. This is the second book. Features, you already know, concept is explained with the help of examples. After each concept, practice exercises are given. Solutions to the practice exercises are available as a QR code. Programs are explained with the help of dry run as and when required. At the end of each chapter, back exercises are given. Amazon link to the book is provided in the description box. The next video is about user-defined methods, method calling and usage of return type in the header. Thank you.